we'll go ahead and get started. Whoops. We'll go ahead and get started. So today we're going to finish up the quiz, which talked about arrays a little. Hopefully everyone's used to arrays, and the array list is hopefully intuitive for all of y'all, because we'll probably be practicing it a little more moving forward. But we'll talk about arrays. We'll talk about a little more about object-oriented design, namely doing inheritance, which hopefully you all read up on. And I think that's going to be it for today. Well, hopefully it won't be too bad. So what's an array?
A list.
It's a list. All right. What in particular about this list?
It's ordered and it has another value that goes with the index value, so you can find things.
So it has an index value. Okay. Why does it? What's the index value? What is that all about?
It tells you the position of items in your list.
Okay, it tells you the position of the items in your list. All right. So how would this be different than other lists? Or have you only done arrays and no other lists?
Well, I mean, I was here last.
Well, yeah, for the rest of the class. I don't know which other.
C++?
Yeah.
We did ordered list and unordered list
Girl, that is
and
not
definition
working.
list.
That is networking. That is not
We did it last night.
Sorry.
We did it last night. Oh, okay. So with an array, your items are contiguous. They are one after another. Not all lists are that way, by the way. In reality, I think arrays are the only ones that are that way. So, and more specifically in Java, an array is actually an object. Yeah, I get this. I guess I'll just keep saying it until it sticks. The array is an object. It's not actually a literal sequence of events. Of items like it is in C++. But it's an object that stores a list of values. The entire list can be referenced by its name, and each element can be referenced individually based on index of the array. It's an object because it's storing not only the list of values, but stores other information like its length. How is each element of an array referenced?
The index.
The index. Okay, great. Remember, we start at 0. Don't ever try starting at 1. You'll be sad. So if you want to get the 6th element, it's sub 5. What is an array's element type? Kind of a backwards question, but go ahead. The type of the array.
Is it primitive or?
It can be a primitive or an object. Are all elements of the array the same type? Yes. It is, yes. Now, they're all the same type. What you're probably confusing is when we talk about inheritance, it may be a subtype of the type, but they're all of some parent type. So they're all integers or they're all objects. So primitives of integers only holds integers. Array of dog types could holds references or pointers to objects of type dog. Would hold? That should be hold. All right. What's this idea of array bounds checking? AKA, what happens when you index outside the bounds of an array?
An error.
It's an error. What type of error?
Out of bounds.
Out of bounds error. What does Java do when you do that?
Gets upset.
It gets upset.
That's when they want to work with you.
It stops working with you. Anyone else? More specifically, what does it do?
It won't compile.
It does compile. It does compile. So the problem is when it runs. When it runs, what happens in Java?
Because after it runs your code up until the error, and then it goes into an error state.
An error state. It throws an exception.
Throws an exception and
Array out of bounds. So it stops your program by throwing an exception. How is this different than C++? Does C++ throw an exception? No, it doesn't throw. No, C++, you just do it. It just does it. And bad things happen will be the easiest way to put it. But yeah, you can take your array and index -1 in C++, and it'll allow it. Or something way past its value, sub 1 million on a 1,000 element array. It'll just do it. What happens? Whatever happens. But specifically, Java will stop you, which is great. So you reference an element in an array. Java ensures that reference is actually legitimate by checking that its index is at least 0 and less than the length of the array, strictly less than. If it's not within the bounds, Java will throw an array out of bounds exception and stop your program. Hopefully you see that's nice of Java, because it tells you when there's an error. Okay, we went over the 8 steps listed in the book for proper O design. This is not the way to do it, but it's definitely a good way to do it. So who remembers the 8 steps?
Is one of them stub it out?
One of them is stub it out. Yes.
Okay. That's all I got.
That's all you got? Stub it out?
Yeah.
When in doubt, stub it out?
Divide and conquer? Is
Divide
that
and conquer,
all? Yeah, I got,
No,
Okay.
not quite.
I love one.
Create your classes first.
Create your classes first. All right. What do you do before that? Y'all doing great, actually, because y'all are stating a lot of steps. But it's very common to forget the first steps you're supposed to do. Actually, what's the very first thing you should do?
Design a plan.
Analysis of the problem. Doing proper analysis. That's what they listed, but it's really just analyzing the problem. What else do we need to do?
Discover a solution.
Discover a solution.
Well, like, like design a map or like, write it out. Like,
Yeah,
steps,
write
like,
the steps out. That's definitely afterwards. But can anyone think of what we talked about between, right afterwards? Remember, you're out of business here, so it's not you just doing a fun project. So before you can actually start designing and everything,
Budget.
budgeting, yeah, you need to do a statement of work is what it is. Yeah, which describes the system. So this gives the business people at least a high-level view of what's going on, because in reality they have no idea what you're doing. It's just the way it is. And that's called the SAL. That word has been thrown around so much. Anyone from a Spay War has probably heard that a lot as well. But it's also used a lot in most industry terms. So after you have the SAL, what comes next? Now you actually get the requirements. What it is that you need. What's hardware you need, software, how many man hours you need, et cetera, et cetera. And then before you actually design it, they usually want a prototype. To prototype the user interface. To at least see what's going on. Now we finally get to the identifying classes. So this is very common. It's actually good that you are identifying classes, because I've had some students say, open up IntelliJ, start coding. Like, okay, well, definitely one of the steps, but we're not there yet. But yeah, definitely identifying classes, but notice there are 4 steps before doing that. And it's important to keep in mind that before you start coding in a large project, where aka more than a couple of people, you really have to sit down and design things first. Otherwise, communication is going to be terrible. All right, we got design classes, determine the responsibility. So first you identify what classes you want, determine what class should do what, division of labor or divide and conquer. Let's see, how they're going to interact with one another. And then lastly, you want to identify a high-level model to describe the system. And this is really something to give back to your program manager who has no clue what you're doing, so they at least have an idea of what is happening, even though they still will have no clue what you're doing. Why are these things important?
So you can go back and look at what you need to do. So you're not just jumping in there and trying to do all of it at once.
Right, you can actually piece it together. Right, so you have your requirements, you've developed what needs to happen, so you can say, hey, look, I got this work done, and maybe you can give a percentage of how much completed is, because they always want to know what percent completed is, which is, I find hilarious, because that last 10% takes 90% of the time. But anyways, right, so you want to be able to jump back. Why else do we want to do this?
Keeps you organized.
Keeps you organized. Why is it good to be organized in this regard?
Especially if it's a big project, you don't want to start mixing in classes that should probably be just keep your code organized, especially if you have other people that are going to be working on it later.
Right, so
Lots of reasons.
there are lots of reasons. No, organized, so you know who's working on what. You don't reinvent the wheel. This person's in charge of that. You can divide make sure everyone's working efficiently or productively.
Didn't you say it was for like the client too, so they can't try and say that?
Right, by doing the whole statement of work and the UI, you're like, hey, look, you signed on this paper saying this is what you needed. We've delivered. Which, we understand there's changes, and then if they want some change, then you can say, okay, that's fine, just cost you more money. Right. As opposed to them saying, well, we agreed to this at the beginning. So yeah, it's good to get it all written out, especially, again, because the client has no idea what you're doing. Okay. It all comes down to why it's important. It's really to increase productivity, which reduces cost and time, and actually possibly save lives. Yeah, if you're working on a piece of medical equipment, you can literally actually be saving lives. Or I guess a weapon system as well of the military. But we'll stick with medical equipment for now.
You're going to be destroying lives.
Yeah, whatever. Well, no, because we're defending ours, so it makes things less and whatever. All right. Like I said, we'll stick with medical equipment. That's better. That's an easier analogy.
Yeah.
All right. Oh yeah. Any questions on these? Very important, especially for your class project. All right. A lot of companies will ask for a prototype before doing any official production build. Why are prototypes so desirable?
They can see what it might look like.
They can see what
See
it might.
if they want it.
See if they want it. There we go.
They're interested.
They're interested. Yeah, so can actually save money like, oh no, we don't want this, or hey, look, this would be great. You may see what the final product looks like. Also provides better feedback because it'll be like, yeah, we don't really care about this feature. What we'd really like is this. That happens a lot, all the time, so be ready for that. Basically, it's also something the client can at least poke around and click on, right? And the end user can finally see something and maybe give you even better feedback, which is really important. So you've at least given a connection between what you're doing and what the final end user desires. List 3 ways to perform proper software design. Okay, that's kind of a vague request, but let's see what we get. How would you do it? Maybe that would be a better word. Would you keep it all in your head and keep it there?
Right in front.
Definitely.
Divide and conquer.
Divide and conquer. All right. Divide and conquer. How would you write it down?
Step by step.
Step by step. Okay.
Like what I was going to do. A detailed plan.
Like an outline.
An outline. Okay. So, yeah, the outline design, or I think you're thinking a little on the requirement side. So on the design, we're actually talking about the code. So how would you do software design, aka how would you design the code of your program?
I would find basically isn't that stubbing it out?
Yeah, so stubbing it out is a great way to do it. That's definitely one way. So load up IDE, your IntelliJ, stub it all out. What was the big thing I talked about last class? I know that was 5 days ago. The weekend has gone by. So UML is a way to do it. Some companies will require it, some will not. But that's with the use cases, the class diagrams, and the sequence diagrams. I'm requiring the use case diagrams for your requirements. Drawing classes on paper or whiteboard. Sometimes you'll walk in and all of a sudden you'll see this giant whiteboard with tons of classes running around how they communicate. It's definitely a way to do it. Stubbing it out in IDE. This is my favorite way of doing it because then you at least, since you don't have code, you just talk about how they're communicating to one another. And then you can at least hit compile and see if the job is okay with what you just did, right? I suggest you do this for your project. Maybe not for requirements for the design, which is going to come next, but for the design, do this. But the one that's coming up that's due, when does that one due? Soon? The 28th. So let's do the 20th. Wow, I gave you a lot of time. Awesome. So with the after the requirements, I highly suggest you bring up an IDE and at least stub out what the code's going to look like. Any questions? Great. What is one reason for the existence of wrappers in OOP? I have many reasons, but I just want one. What was the big wrapper we talked about last time?
The integer.
Okay, integer was one wrapper, yeah. Why do we... That one's hard to really understand the wrapper on that one, unless you...
So, what about the array list?
Yeah, the array list is a great example. Why does that exist?
It's a lot easier to use. You can just call functions off of it.
But still provides the same
Yeah, it still provides the same capabilities, but it's a lot easier to use.
Right. So it uses what's really going on. It's using code designed by someone else. Because in the array list, if I was to bring up the implementation, it uses an array. The array already exists. Someone already wrote how an array works inside of Java. The array list just takes it and expands upon it, so it's easier to utilize. So one thing is you get to use someone else's code. So someone else has already written part of it for you, which means it's already been tested by someone else, so you don't have to test that part. And it's already been designed as well. You just need to add what you want to it. Okay. Any questions over this quiz? No questions? Comments? Screams amongst? All right. So read chapter 8. Again, these are short. Hopefully you've noticed the chapters in the object-oriented thought process are pretty short. And then start getting to chapter 3, sections 1, 2, and 3, which is going to talk about inheritance, which is what we're going to go over pretty soon. Go ahead and stop the recording.